Hey guys, welcome back to Studying with Zahra. Today we're going to be doing Unit 7, which is Radioactivity and Particles, and we're going to be doing ionizing radiation, alpha, beta, and gamma decay. So in the last video we went over the structure of an atom, atomic configuration, we went over isotopes, examples of isotopes, and atomic notations. And we briefly went over what happens if we have too many or too few neutrons in the nucleus. So we're going to start with ionizing radiation. And basically, in simple terms, ionizing radiation occurs when unstable nuclei decay. They're going to emit ionizing radiation. So I have my unstable nuclei right here, and this is going to emit ionizing radiation. And basically, ionizing radiation causes atoms to gain or lose electric charge. So I'm going to make a little flowchart kind of a situation. Unstable nuclei, ionizing radiation, and then as a result, atom plus / minus, so gain or lose charge. And as a result, it will form an ion, hence the name ionizing radiation. Unstable nuclei will decay at random. So this is a very random process. It's not predictable. You can't predict which unstable nucleus in a piece of radioactive material will decay or when the decay will occur. And we shall see that we can make measurements that will enable us to predict the probability that a certain proportion of a radioactive material will decay in a given time. But we can't predict exactly which unstable nucleus will decay. So it's random, and we can only predict the probability that a certain proportion of radioactive material will decay in a given time. Probability that X proportion, I'm going to write prop for short, of radioactive material will decay in Y time. So Y is going to be a variable. It could be like 5 minutes, 10 minutes, probably a bit more. Okay. So there are 3 basic types of ionizing radiation. I'm going to use 3 different colors for this. We have alpha, beta, or beta, however you pronounce, and gamma. And we're going to start with, you guessed it, alpha radiation. It consists of fast-moving particles that are thrown out of unstable nuclei in decaying. And these namely alpha particles. So these fast-moving particles are called alpha particles. Alpha particles are also known as helium nuclei. Now this might be a little bit of a confusing concept. But they're basically helium atoms without the shell. That just means without. And this is what it's gonna look like. This is what our alpha particle consists of. So we have our neutrons and our protons, and these together form a little helium nuclei. And they have a relatively large mass. Mass number is 4. And they're also charged because of the 2 protons that they carry. The relative charge of an alpha particle is +2. Not relative mass, sorry. That would be relative charge. So I'm gonna stop writing for a second and we're just gonna verbally go over the alpha particle. So, the alpha particle has a short range. The range of ionizing radiation is the distance it can travel through matter. Alpha particles can only travel a few centimeters in air and cannot penetrate more than a few millimeters of paper. So they can't travel very far. They're very short range. And they have a limited range because they interact with atoms along their path, causing ions to form. So alpha radiation, as it's going through the air or paper or whatever medium you put it through, it's gonna interact with the atoms that it finds along its path. And in doing so, it's gonna cause ions to form. This means that they rapidly give up energy that they have when they were ejected from the unstable nucleus. So they have lots of energy when they're coming out of the nucleus, the unstable nucleus. However, because they interact with the atoms that they come across as they're traveling, they lose all of this energy. And they cause ions to form. And as a result, they tend to be very short range. They can't travel very far. Again, it can only travel a couple centimeters through air, a couple millimeters through paper, which isn't very much. On the other hand, beta particles are a little different because we have 2 types of beta particles. We have beta minus and beta positive. So beta minus particles, just like alpha radiation, are very fast moving electrons. So our alpha radiation was a helium nucleus, but our beta is an electron. It's not a nucleus. Beta minus particles are very fast moving electrons, and they are ejected by a decaying nucleus. Alpha particles are also ejected by a decaying nucleus. The nucleus of the atoms contains protons and neutrons. So where does the electron come from? The stability of the nucleus depends on the proportion of protons and neutrons it contains. And the result of decay is to change the balance of protons and neutrons in the nucleus to make it more stable. So beta minus decay involves a neutron in the nucleus splitting into a proton and an electron. Now this might sound a little bit confusing, but basically you have your neutron, and it's neutrally charged, and it splits into a proton and an electron. And an anti-neutrino is also emitted, but we're not going to be talking about that. The proton remains in the nucleus, and the electron is ejected at high speed as a beta minus particle. So you can imagine nucleus to be a pair of people in this situation. And there's one positive person and there's one negative person who's always sad. Positive person's always happy. And they're both together. They're glued together really tightly, okay? Normally, in any other case, they would never come apart. But in this specific scenario, in this specific situation, they are going to be separated. And the proton is going to want to, the positive one is going to want to stay in the pair. But the negative one is going to go sprinting out of here. It's going to get ejected at a very fast pace, at a very fast speed from the decaying nucleus, which you can kind of consider to be the decaying friendship. Now, it's just an analogy, but it might help explain, or it might help for you to remember how beta radiation works. So beta particles are very light, and they're only 0.000125 times the mass of an alpha particle. So the relative charge of a B negative or B minus is -1, and the relative charge of a B positive is obviously going to be a +1. Beta particles interact with matter in their path less frequently than the alpha particle. This is because they're smaller and they carry less charge in comparison to the bigger, highly charged, as we mentioned, the alpha particle has a +2 charge, the beta would have -1 and +1, so it's a less charge. This means that beta particles can travel a greater range than alpha particles. So alpha particles, as we mentioned, only travel a few centimeters through air and a few millimeters through paper, but beta particles, on the other hand, have a greater range. They can travel long distances through air, pass through paper easily, and are only absorbed by denser materials like aluminium. A millimeter or two of aluminium foil will stop all but the most energetic beta particles. And lastly, we're going to be talking about gamma rays, and then with that, we're going to end this kind of portion of the topic in this video as well. So gamma rays are electromagnetic rays, and we talk about these in the waves topic, but basically they have very short wavelengths. And as they are waves, they have no mass and no charge. They are weakly ionizing. So let's just briefly go over a few of the qualities of gamma rays. Short wavelengths, waves, no mass, no charge, weakly ionizing, and interact only occasionally with atoms in their path. They're extremely penetrating and pass through all but the very densest of materials. So really low interaction, highly penetrating, and they can actually cause cancer as a result in humans. They pass through all but the densest of materials with ease, and it takes several centimeter thickness of lead or a meter or so of concrete to stop gamma radiation. So as you can tell, highly penetrating. Anyways, that's it for today's video on ionizing radiation, the different types of ionizing radiation. Let me know if you want to see anything else, any other future video ideas, just pop them in the comment section. And that's pretty much it for the video. I'll see you guys next time.